Hello everybody, it's Mr. Ray here. I'm going to start a new week of some calculus lessons in our unit that's introducing calculus. So we have 3 lessons this week. This will finish off the unit like I just said. So we will have an assignment that's based on uh, these 3 lessons plus what you've learned last week as well. So the next 2 lessons are regarding the limit of a function. Um, So this first lesson, we'll be talking about what that is, and then the next lesson we'll get into the properties. And then the final lesson is on continuity of functions. Okay, so they are related, but they're different. So it's very important that you understand the difference between a function's limit and its continuity. You would think they're kind of the same, but there is important differences that you have to understand. Okay, so you can see on the screen we've got our lesson, limit of a function. So the rate of change, that's what we did last unit. That's basically how quickly the dependent variable changes with respect to the independent. And we had average rate of change and instantaneous rate of change. Instantaneous was like the slope of the tangent at a point. Okay. So what's the limit of a function? It's the value that a function approaches from both the left and the right side of the independent value. So independent value, that's just x. So you can pick a value for x, and the limit of a function may or may not exist. We'll talk about that. But if it does exist, it'll be the number that the function, basically the y value of the function, um, as it's approaching from both sides of x, from the positive and the negative side. Okay, so formal definition here, and the way we write it's very important. You have to do the same thing. You can't come up with your own way of writing this. So the limit of a function y equals f of x at x equals a. So this is where we're determining a would be the point we're seeing if it has a limit. We write this as the limit as x approaches a. So a will be the x value that we're kind of measuring the limit at. So the limit as x approaches a of f of x, they'll be written as capital L just represents that y value. What is the function approaching? Okay. Now it's important that we look at both coming from the left side or from the negative side of a and from the positive side of a. We can actually look at each limit separately and then compare. And if those two limits are the same, then we say L would be the limit. Now, if they're not the same, say the function's approaching a different value from the left compared to the right, then we would say the limit does not exist, or it's not defined. We also have a short form, DNE, stands for does not exist. You'll see that in the lesson, and I believe in the textbook too. So now, we didn't really talk about, well, you'll see this in examples, but the value of the function at a really doesn't have any relevance, and you would think that it does, but all we're looking at is what is the function approaching as we come from the left and the right side. It doesn't actually have to be the same as the value of the function at that point. Okay, I know it sounds a little confusing, but it can be equal or it does not have to be equal to, and you'll see that. Okay, so, and the way we break the two left side, right side limits, I know it's a little hard to see here, but you could say if the limit as x approaches a, and there's a little negative prefix or superscript here, a negative, that means the limit as x is approaching a from the left side. So this would be the limit from the left side. We can say that's equal to L. And if the limit also as x approaches a from the right side or the positive side of a, if that limit is the same, if the y values are the same from the left and the right side, then L is the limit as x approaches a generally. Okay, so let's do some examples here to see what we're talking about. We've got a function here. Oh, there was a little mistake here, so I just want to correct that. This should say right side here. I don't know. I don't seem to ever correct that, but obviously it's not left side and left side, it's left side and right side. Okay. Now we have a little table of values for this function, y equals x squared minus 1. And what we're trying to do is find the limit. Now this is just the first function, but as x approaches 2. So this is the key point. So we have, you can see we've got x equals 2, but we've also got values approaching 2 from below 2, like from 1, we're getting closer and closer. We have some values that are really close to 2, and we've also got some values approaching from the positive side or the right side of 2. So if I plug in, if I just do some calculations here, if I do the integers quickly, that would be a 0. Plug in at 1, we get 0. Plug in at 2, we get 4 minus 1 is 3. And if we plug in 3, we get 9 minus 1 is 8. Okay? Now you would think, that as we come from the right side of x equals 2, that the f of x should be approaching 3, based on what we see here, but that's not always the case. So we're actually going to see what is happening as we're getting closer to 2, x equals 2 from both sides. So if we actually do the calculations here, I'm just going to do them very quickly here. 1.5 for x means y is 1.25. We have 2.61 if x is 1.9, 2.96 for 1.99, and then I think it's 996. So you can see it's getting really, really, really close to 3, and you could make the assumption that the limit as x approaches 2 from the negative side of 2 is 3. So the limit, even though, we should be kind of ignoring this actual value here for the time being and seeing what's this progressing towards, because it may not match that. It does in this case, but you have to be looking at what's the pattern of numbers here as we come closer and closer to x equals 2 from the left side. Same thing from the right. So if I plug in these coming from the right side, 5.25, 3.41, 3.04, and 3.004, I believe. And you can kind of see the same pattern come from as x is approaching 2 from the right side. The limit of the function, or f of x, is approaching 3. So the way we write this, we do two separate limits here. So the limit here would be limit as x approaches 2 from the negative side of f of x is equal to 3. It's going towards 3. And the limit as x approaches 2 from the positive side of f of x. So what's happening to f of x, or y, as we get closer? It's also 3. Now, as long as these two limits are the same, in other words, 3 equals 3, then we can make a conclusion, and we can take away the positive and negative. We can just make it the limit as x approaches 2 of f of x is equal to 3. Now, just to make the point clear, if for some reason the value of this function at 2 happened to be something other than 3, say it was 20, if that value there was 20, that wouldn't have changed what these limits are, because you can see it's approaching 3, it's approaching 3, the limit would still exist and it would be 3. So like I said before, the actual value at x equals a, where we're taking the limit, really doesn't have any play in what the limit is of this function. Okay, it seems a bit strange that it doesn't have any relationship, but it will, once we start talking about continuity, we will be looking at the actual value at that point and not just the limits. Okay, we're going to continue on with a couple more functions here. And remember, the question was, what's the limit as x approaches 2? Another typo here, this should be x minus 2 squared. Okay, so again, we're approaching x equals 2, and you can see we're coming from the positive side of 2 and coming from the negative side of 2. Okay, now if you were to plug in x equals 2 here, you'd see that you get 0 on the bottom, and that would be undefined. So I'm just going to put a u here for undefined. If the value is 1, if you plug 1 in, you're going to get -4. And as I increase the value closer and closer to 2, you can see I get -9, -49, -499, and -4,999. Okay, so the conclusion I can make, and again, you basically ignore that value. So what's happening to f of x as x approaches 2 from the negative side? It looks like it's approaching negative infinity. Okay, so I'm going to make that conclusion before I even do the other side, because it doesn't even matter what's going on the other side. As x approaches 2 from the negative side, the limit of f of x is equal to negative infinity. Okay, if we do it from the right side, if I plug these values into the function, I get 6, 11, 51, 501, 5001. So you can see it's getting extremely high, and if you keep plugging in even smaller values above 2, it's going to get higher and higher. So the limit on this side is actually positive infinity. So the limit as x approaches 2 from the positive side of f of x is equal to positive infinity. Okay. So if I compare these two, I can see they're not the same. So the limit as x approaches 2 of f of x, we'll say, does not exist, because there is no limit as we come from both. The limit is not the same from both sides, so therefore the overall limit at that point does not exist. Okay, remember that DNE stands for does not exist. Now if you were to actually graph this function, you'd see what's going on here. You know there's a vertical asymptote at x equals 2, and we're going to have this reciprocal function that looks like that, and you can see exactly what's happened. So it's a kind of a diverging away from each other. So you can see why the limit doesn't exist. This side is going to negative infinity, this side's going to positive infinity. They're not the same. They're not headed to the same place. Okay, let's try one more. Here's another rational function. Now this one here, if you do some advanced functions work here, you know that's a difference of squares. And you can see that you have x minus 2's cancel, and you have an x plus 2 left overall. Now, when you have something like this, where you have a factor in the numerator and denominator that cancel, that means there's a hole where that factor is 0, so there's a hole at x equals 2. That just means it's not continuous. There's a break. Okay, that doesn't really tell us whether it's what the limit is. It just says there's a break there. Okay, so if we were to plug in our values here, so again, if I plug in x equals 2 here, again, I get a denominator of 0. That's in the original version, so it's undefined, and that's where the hole comes in. If I was to start filling in values here, so x equals 1 at 3, 3.5, 3.9, 3.99, 3.999, and you can it's pretty apparent that this limit is approaching 4 from the left side. So we would write that as the limit of f of x as x approaches 2 from the negative side, from the left side, is equal to 4. Okay? And if we do the same thing over here, if I plug in 3, I get 5. 2.5 gives us 4.5, 4.1, 4.01, 4.001. And again, you can pretty easily see as we get closer and closer to 2 from the right side, that limit is also 4. So I'd write it as its own. We call these one-sided limits because it's just coming from one side, not both. X approaches 2 from the positive side of f of x. That's also equal to 4. So the fact that these two are equal tells us that the general two-sided limit, x approaches 2 of f of x, since these two are both 4, the overall limit does exist and it is 4. Okay. So if you hear one-sided and two-sided limits, that just basically means two-sided. You're looking coming from the left side and the right side. What is the limit? Two-sided means you're coming from the left side and the right side. So you have to look at each individual one-sided limit to determine if the overall two-sided limit exists. Okay, so this last question, usually a few questions like this on a test or assignment, so make sure you can do this. These are piecewise functions, okay? So what it means is you've got a function f of x, and depending on the value of x, it has a different equation, a different formula for the function. Okay, so you can tell if you look at the if statements here, you've got f of x equals 1 when x equals 1. So x equals 1 is kind of like the division point. So you've got a value of the function at 1, and then if x is less than 1, you've got this other calculation or value here for f of x. And if x is bigger than 1, you've got a third formula. So basically it's going to break the function up into 3 pieces. Okay, that's why I call it piecewise. If you're to do, and it's important that you're able to do a sketch because you can almost answer the question from the sketch. So obviously at x equals 1, that's the critical point. So if I just do a couple more values here, here's my x, here's my y. So when x equals 1, f of x equals 1. So I know there is a point there. Okay. If x is less than 1, it's basically x minus 1. So you can think of this almost like a line. This is the line y equals x minus 1, so it has a slope of 1, y-intercept of negative 1. Okay, so you know it's going to go through there. Slope of 1 means it comes up through here. So the function basically goes down here. Slope of 1 going through negative 1. Now how do I show what's going on here? Well, this line does not contribute to the function at x equals 1. So this is where you put the open circle. So it basically begins for everything less than x equals 1, the function is defined by x minus 1. When x equals 1, it's defined by the value 1. And then the last one, I'm just going to show you what that looks like. If you actually plug in x equals 1, this would be 0. So you would get a value of 2. Y equals 2. So that value of 2 does not really occur because that's when x equals 1. F of x would be, or y would be 2 here. But anything above, it'll basically look like a transformed square root function. So it's something like this. Okay, so this function has 3 pieces to it: x less than 1, x equal 1, x greater than 1. So when I'm looking at this, if I want to determine the limit as x approaches 1, I'll break this up into the two parts. So I've got the limit as x approaches 1 from the negative side of f of x. Okay, so that's where's this function headed towards? And we kind of determined, we plugged in the line here, if it could actually get to 1, x equals 1, the value of the function of x minus 1 would be 0. So the limit from the left side is 0. Okay, if you look at the limit from the right side, x approaches 1 from the positive side for f of x, that would be coming from the right side. So where's this curve headed towards? It's headed towards x equals 2. And we got that value by actually plugging in x equals 1 to find out where it would get to if it could get there. Okay, so this limit is equal to 2. You can see that here. This side goes to y equals 2. This side goes to y equals 0. The actual value of the function at x equals 1 is 1. Okay, but you can see that value has no bearing on the actual limit. These two limits do not agree with each other. They're not equal. So therefore the limit as x approaches 1, this is the two-sided limit of f of x, does not exist. Okay? All right, so hopefully, when you're drawing your piecewise functions, see where the breakpoints are. In this case, it was x equals 1, so you're going to get, different values, maybe when it's equal to, maybe when it's greater than, maybe when it's less than, but this is the key thing that you always start looking at first, and this is where the function breaks into its pieces. Okay? Okay, so I got some homework there. I've also got a handout. I'm going to have a look at that. Now it's pretty small writing. I'm going to try to zoom in on this. So this handout is included in Google Classroom. So it's got a graph, and you can see this is a pretty complicated piecewise function. We've got a curve that goes up to x equals, so this is as x approaches -4 from the left side. This is x approaches -4 from the right side. So there's a breakpoint there, there's a breakpoint at -1, and there's a breakpoint at 4. So there's some questions here. Let's do this first part together. The answers to these graphs are at the bottom of the next page. So try them first, make sure you get the right answers. Okay, so the first question, very small writing, is the limit of f of x as x approaches -1 from the negative side. So here's x equals -1. X approaches -1 from the negative side. The function is approaching that point right there, which is y equals 2. So that limit would be 2. It's approaching 2 from the left side, or the negative side. Okay. Next question, the same idea, but this time as x is approaching -1 from the right side. So as we're coming along the right side, what are we getting closer and closer to? We're getting closer and closer to, again, 2. And then the third part here, what is the overall two-sided limit? Well, you can see graphically they're both headed towards the same place, but you can also see in this notation that the limits are equal, and if the limits are equal, that is the overall limit. Okay, the limit does exist, and it is that value. Okay. Now you notice if they asked us what f of -1 was, f of -1 is 1, which is different from these limits, but it does not play into whether this limit exists. Like I said, that actual point there could be anywhere along here, and it doesn't matter. Okay, you can see at that point, I've kind of smudged it a bit, but that would be an open circle because the actual value at x equals -1 is 1, not 2. Okay, then we got two limits here. These are two-sided limits. Limit as x approaches -4 of f of x. Now, you notice it doesn't have the plus or the minus here. So we have to actually look at both sides. So at -4 here, as x approaches -4 from the negative side, the limit would be here, which is 3. As it approaches -4 from the right side, the limit would be 4. Those are not the same value. So therefore, the overall limit as x approaches -4 does not exist, because the two one-sided limits are different. Okay, and the last one here, limit as x approaches 4, you have the same situation, because you have one limit that's approaching -3, and the other limit, the other sided limit is approaching -2. These values don't match, so this also does not exist. Okay, so when you're doing these limits, make sure you're checking if it's a one-sided limit with the plus or minus side, or if it's the two-sided limit, you still have to look at the two one-sided limits and see if they agree. And if they do, like these two did, then the overall limit is that limit. If they don't agree, then the overall limit does not exist. Okay, hopefully that helps. If you're still having issues with these questions, please join me on Tuesday for the extra math help during my online office hours. Okay, all right, thanks, and have a good day.